Learning mathematics is very, very difficult to many people, second only to learning how to speak English. Do you have difficulty? Don't be embarrassed. It's a lot of people don't know what they're doing when they get up there and do their mathematics. We're going to introduce you today to Fort Bend tutoring, honey. Personalized math tutoring is the solution.
Hello ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be about system of linear equations using the substitution method. Alright, let's check that out. We're going to start out with our first problem today. Alright, with problem number 1, we have a system of linear equations. In all of these problems today, we'll be looking for the intersection. These are two lines, ladies and gentlemen, and we're looking for where these two lines cross. That's all we're doing. So in the majority of these problems, we'll have a point as a solution. When you're dealing with a system of equations, you can have three outcomes. You can have a point where you actually have a value for x and y, or it can be the exact same line. So in that case, every point on the line is a solution. Or you can have a situation where they're parallel lines, and in that case you have no solution. So let's find out what happens here. In an ideal substitution problem, one of the four variables that you may have will be already solved for. So if you notice, I have an x and a y in the first equation and x and a y in the second equation. However, in the second equation, this variable x has already been solved for. It's isolated. It's by itself on one side of the equal sign. And it's telling me that y plus 1 equals to x. So if I wanted to make note of that, I can say, oh, well, x equals to y plus 1, and therefore I'll be able to substitute this value of x into the first equation. So that's exactly what I'll be doing. I'll be rewriting the first equation knowing that x is equivalent to y plus 1. It'll look like this. I'll have y plus 1 plus y equals to 5. Just like that. So notice how I replace the value of x with y plus 1, and then I continue to write the rest of the equation. So combining my like terms down here, y plus y is 2y plus 1, which equals to 5, and then I'll be subtracting 1 to both sides now. This gives me 2y equals to 4, and then I'll be dividing both sides by 2. So after I divide both sides by 2, I'll have y equals to 2, and that's it. Okay, now that I know that y equals to 2, in order to find out what the value of x is, we can plug it back into that second equation. Since we know that x equals to y plus 1, we have now solved for y, which is 2, so 2 plus 1 gives me a value of 3. So my answer as an ordered pair is 3, 2. And that's the point of intersection. That's what we were looking for, where these two lines, these two linear equations, where they intersected. Done and done, ladies and gentlemen, and that's the substitution method when solving a system of equations. Let's look at some more examples, shall we? Alright, in problem number 2, I have x minus 2y equals to 8 and 2x plus y equals to 8. Remember, when using the substitution method, you want to solve for one of the four variables that may be given to you. The easiest variable for me to solve for would be this x in the first equation. So what I'll do is I'll go ahead and rewrite this first equation, which is x minus 2y equals to 8, and I'll solve for x. So by adding 2y to both sides, I'll end up with x equals to 2y plus 8. So I know that my variable x equals to 2y plus 8. Once you solve for one of your four variables that you may have, go ahead and you'll plug in that result into the other equation. Never the same equation, ladies and gentlemen, all right? So what I'll do is, since I solved for x in the first equation and I know that x equals to 2y plus 8, I'll plug in this result in for x in the second equation. So I'm rewriting the second equation as 2 times the quantity of 2y plus 8 plus y equals to 8. And that's what I have thus far. So remember, this value of x is being rewritten as 2y plus 8 because that's what we solved for out of that first equation. From here, I can distribute and then go ahead and solve for my variable y. So I'll get my arrows popping here, and 2 times 2y gives me 4y plus 2 times 8 is 16 plus y equals to 8. From here, we'll combine our like terms. 4y plus y gives me 5y. So I have 5y plus 16 equals to 8. I'll be subtracting 16 to both sides of my equal sign, and 5y equals to negative 8. From here, I'll be dividing both sides by 5. So my result is y equals to negative 8/5. And that's the result that I get for y. Okay, now that I have that, I can find out what x is now by plugging in that value back into our equation where we solved for x. So x equals to 2 times my y value, which is negative 8/5, plus 8. All right? So let's see what happens here. Multiplying straight across, 2 times negative 8/5 will be negative 16/5 plus 40/5. And that's just simply me rewriting 8 with a denominator of 5. From here, I can go ahead and combine those like terms and find that negative 16/5 plus 40/5 is going to give me a positive 24/5, which is my result for x. Okay? So now that I have that, I can write my solution as an ordered pair. So the result will be 24/5 and negative 8/5 for my y value. And that's the answer. So remember, these are points of intersection. So you'll need an x and a y value to find out where that point is. And that's the answer for problem number 2. Okay. In problem number 3, we have the following problem. We have 5x minus 2y equals to 3 and negative 15x plus 6y equals to negative 9. Once again, what we'll do first is we'll solve for one of these 4 variables here. To me, the easiest variable that I can solve for is going to be x in the first equation. So I'm going to take this first equation and solve for x. So I have 5x minus 2y equals to 3. I'll be adding 2y to both sides of the equal sign here. This gives me 5x equals to 2y plus 3, and then I'll divide everything by 5. So dividing everything by 5, here I have the following result. It'll be x equals to 2/5 y plus 3/5. And this will be my value for x for now. And so now I'll be plugging in this value into the second equation. So I'll rewrite this as negative 15 times 2/5 y plus 3/5 plus 6y equals to negative 9. So then I'll be distributing by negative 15. So let's see what happens with that. I have my arrows popping. 5 goes on a negative 15, negative 3 times, and negative 3 times 2 gives me negative 6y. Then 5 goes into negative 15, negative 3 times, negative 3 times 3 is negative 9, plus 6y, which still equals to negative 9. From here, I'll be combining my like terms, and what happens is the 6y's will cancel out, ladies and gentlemen. All right, those are additive inverses. So I have negative 9 equals to negative 9. So notice that I no longer have my variable y in this problem, do I? So in a situation like this, ladies and gentlemen, you look to see if this is a true statement or a false statement. So is negative 9 equal to negative 9? Exactly, it really is. So therefore, this is a true statement, which means that the answer is going to be x and y. It's such that 5x minus 2y equals to 3. Because as it turns out, ladies and gentlemen, your original equations were identical, all right? Meaning that if I would have multiplied this first equation by negative 3, I would end up with a second equation. So anytime you end up with the exact same line, you'll have an infinite number of solutions, ladies and gentlemen. You'll have an infinite number of solutions. So one of the ways to write that is simply by saying, hey, this is the same equation, x and y, is such that anything that makes this equation true will be the solution of the original system of equations. That's it. All right. So there you have it, ladies and gentlemen. That's problem number 3. Let's look at problem number 4 here. In problem number 4, we have the following problem. We have 2x plus y equals 15 and 4x plus 2y equals to 23. So once again, we'll solve for one of these 4 variables that you see in the equation and plug the result into the other equation, the opposite equation. I'm going to take the first equation because I'm thinking that this y in the first equation is a lot easier to solve than the other variables that we have in the problem. So I'm going to take my first equation, this 2x plus y equals to 15, and I'll solve for y by subtracting 2x to both sides of the equal sign. This gives me a result of y equals to negative 2x plus 15. So this is the value that I'll be plugging into the second equation. So instead of writing 2y, I'll be writing 2 times this negative 2x plus 15. It'll look just like this. Rewriting the second equation, we'll have 4x plus 2 times my value of y here, which is negative 2x plus 15 equals to 23. From here, I'm going to distribute. So I got my arrows popping, my favorite property in the world, and I'll bring down my 4x. 2 times negative 2x is going to be negative 4x. 2 times 15 is 30, and this equals to 23. Now, what happens to those 4x's? 4x minus 4x is what? Say again? Right, it's 0. Yeah, it cancels out. So notice that we are left with 30 equals to 23. Well, ladies and gentlemen, does 30 equal to 23? Of course it doesn't. It's 2 different numbers. So since these don't equal to one another, in other words, because this is a false statement, ladies and gentlemen, that's right, we have no solution. And the reason for that, ladies and gentlemen, is their original equations here were parallel. Anytime your lines are parallel to one another, they'll never intersect. Therefore, you'll never have a point of intersection. That's why your solution is the null set. There is no solution. You got it. So there you go, ladies and gentlemen. Number 4. That type of problem, ladies and gentlemen, is a contradiction, and that occurs when you have parallel lines. All right. Number 5. What happens when you have a system of equations that's riddled, I say, with fractions? What do you do then? Well, what I'll do is I'll just rewrite the problem. So anytime I have a system of equations where I have fractions within it, all I'm going to do is just multiply everything in both equations by its common denominator. So the common denominator in the first equation, ladies and gentlemen, is going to be 10. So multiply the whole thing, every single term, by 10 in that problem. In the second equation, you're going to multiply everything by the common denominator of 5. Okay, so let's see what happens when I do that. Multiplying 1/2 times 10, that gives me 5x. Then 10 goes into itself once, that leaves me with 3y. And then 5 goes into 10 twice, so I'm left with 2. That's it. I multiplied each term by 10. Then in the second equation, my second equation's lowest common denominator would be 5. So multiplying 5 times 3/5, the 5's cancel out, that'll leave you with 3x. Then multiplying y times 5, we have 5y. And then multiplying negative 2/5 by 5, the 5 will cancel out to leave you with negative 2. So here is my system of equations rewritten without any fractions. From there, I can then attack the problem by solving for one of the variables. And I believe, ladies and gentlemen, that I'm going to choose this second equation here, and I'm going to solve for x. So in solving for x, I'm going to subtract 5y to both sides of the equal sign. This is going to give me 3x, which now equals to negative 5y minus 2. Then I'll divide everything by 3. And I will end up with x, which now equals to negative 5/3 y minus 2/3. And that is what I have for x for now. I'm going to use this amount right here to substitute into my first equation. And not the first equation with the fractions, but this first equation right here that I've rewritten. Now, this will become 5 times negative 5/3 y minus 2/3 plus 3y, which equals to 2. All right, so what we did there was I replaced the value of x in that first equation with our quantity of negative 5/3 y minus 2/3. So distributing this, ladies and gentlemen, and I'll go ahead and separate this here, we'll have negative 25/3 y minus 10/3 plus 3y equals to 2. If you want to get rid of these fractions, which I really do, go ahead and multiply the entire equation by 3. Okay? Multiplying the entire equation by 3, you'll end up with negative 25y minus 10 plus 9y equals to 6. Okay? Combining the negative 25y and the positive 9, you'll have a negative 16y minus 10 equals to 6. And then I'll add 10 to both sides. And this gives you negative 16y, which equals to 16, and we'll divide both of those by negative 16. So what you'll end up with now is y equals to negative 1. So now that you know that y equals to negative 1, we'll plug that into where we have x isolated. So this is going to be x equals to negative 5/3 times negative 1 minus 2/3. From here, that negative 5/3 times negative 1 becomes positive 5/3 minus 2/3, which is 3/3. Well, ladies and gentlemen, 3/3 equals to 1. That's it. So x equals to 1. Knowing that, my solution is going to be 1, negative 1. Remember, as an ordered pair, you always write your x value first and then your y value. So what happened in this problem, problem number 5, we started out with a system of equations that was riddled with fractions. So I multiplied the first equation by the common denominator of 10. That meant 10 times 1/2 x, 10 times 3/10 y, 10 times 1/5, and ended up with a result of 5x plus 3y equals to 2. Then I took our second equation that had a common denominator of 5 and multiplied each and every term by 5. So 3/5 x times 5, y times 5, negative 2/5 times 5 gave me a result of 3x plus 5y equals to negative 2. From there, we went ahead and solved for x in the second equation and plugged that value of negative 5/3 y minus 2/3 into the equation that we had without fractions. Plugging that in, we worked it out, and y equal to negative 1. Once we found out that y equal to negative 1, ladies and gentlemen, we plugged that value of negative 1 back where we had x isolated and solved for that value of x, which is positive 1, and that gave us a result of 1, negative 1. I know, right? A lot of steps, but you can do it, so take your time with it. Okay. Next problem, ladies and gentlemen, and the last problem of this lesson, we have decimals. That's right, we have decimals. So here in this problem, we have 3 3/10 x plus 6 6/10 y equals to negative 6 6/10. And then we have 1/10 x minus 4/10 y equals to 28/100. Well, just like when we have problems with fractions, you can also take care of your decimals by multiplying by the smallest place value. All right, and if you need to see that technique done, just like with the other problem with the fractions, you can check out our videos. One is called Solving Linear Equations with Fractions. I show you how to clear out the fractions in that video, and you can also check out the one called Solving Linear Equations with Decimals, as I show you how to clear out those decimals. So here I'll be multiplying the entire equation by 10, and I'll be multiplying the entire second equation by 100 because we have the hundredths place shown in our second equation. So let's see what happens when I rewrite it. Multiplying 3 3/10 times 10, I'll end up with 33. So this is now 33x. Plus 6 6/10 times 10 is 66y. Negative 6 6/10 times 10 is negative 66. Just like that. Then, in the second equation, I'll be multiplying by 100. So this becomes 10x minus 40y equals to 28. And that's what I have thus far. So what I'll do, ladies and gentlemen, is I'm going to solve for x in the first equation. All right? So let's check it out. Let's see what happens. Rewriting this, I have 33x plus 66y equals to negative 66. I'll be solving for x by subtracting 66y to both sides of the equal sign. This now gives me 33x, which equals to negative 66y minus 66. From here, I'll be dividing everything by 33, and this gives me a result of x equals to negative 2y minus 2. So I'll be replacing every x in the second equation with negative 2y minus 2. So let's see what that looks like. All right, I'm going to go ahead and put a line of separation there and show you that this second equation here, I'm going to plug in for x, negative 2y minus 2. All right, so I'll rewrite this as 10 times negative 2y minus 2 minus 40y equals to 28. Okay, so that's what I have thus far. I will now distribute. So my favorite property calls for arrows popping. So 10 times negative 2y gives me negative 20y. 10 times negative 2 is negative 20 minus 40y, which equals to 28. From here, we'll combine our like terms. Negative 20y and negative 40y give me negative 60y minus 20 equals to 28. And then I'll be adding 20 to both sides. So I now have negative 60y equals to 48, and then I'll be dividing both sides by negative 60. Dividing both sides by negative 60, I'll have y equals to negative, both of these numbers can be reduced by 12, so that'll be 4/5, which is going to be negative 8/10. as a decimal. Remember, since we started with decimals, ladies and gentlemen, we'll end with decimals. So here I want to rewrite this negative 4/5 as negative 8/10. So this is the value I'll be plugging in to where I have x isolated. So x equals to negative 2 times negative 8/10 minus 2. This gives me a positive 1 6/10 minus 2. So my result here for x is equivalent to a negative 4/10. So that's the result there, ladies and gentlemen. So 1 6/10 minus 2 gives me negative 4/10. With this, ladies and gentlemen, I can write my ordered pair as negative 4/10 and negative 8/10, and that's the answer, ladies and gentlemen. That's it. All right, so that's how to tackle a system of linear equations when you have decimals in it, ladies and gentlemen. That's right. Multiply by the smallest place value. That'll clear out those decimals, and there you have it. Ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and this was Systems of Linear Equations using the Substitution Method. As always, please rate, comment, and subscribe, and as always, if you're able, please donate. Peace.
We certainly hope you enjoyed today's presentation by Fort Bend Tutoring. Did you understand the program? Would you like to rate us or give us some feedback or subscribe to us? Leave a nice comment. Don't just leave something ignorant on there. If you didn't understand the lesson, ask the professor to explain it for you. Don't just get mad and write something ignorant on there.